Hello, a little while ago I made this funny flying tail sort of thing, and I did that by taking lots of little pieces of wood and gluing them together, and rather surprisingly I actually kind of enjoyed that. I've never really been much for using glue to put things together. I've sort of preferred to use screws and bolts as I did with my cheap-ass quadcopter years ago, if I can. But once you use glue a bit more and you sort of learn what is the best glue for what situation and material and how strong each of them is and so on, it's not so bad. So I actually sort of enjoyed it, and I got it into my head that I might like to do that kind of thing a little bit more in the future. It's so much so that I actually almost bought one of these kits on Banggood, sort of a balsa laser cut kit that you can just put together and build a plane from. But I thought, rather than doing that, what if I try and design my own plane again? And since I'm living here now in a place where, if I just turn around and look out the window there, we'll see lots of nice open countryside, and just up there on the other side of that hill there's actually an airstrip, so there's plenty of space, flat open space rather. Those hills are not very good for landing and taking off from, but I thought that top area up there where the landing strip is at least it's flat, but it's all gravel. But if I had the right kind of plane, I thought maybe I could still take off from that rough landing strip. And at the same time, I've been watching a lot of videos on YouTube by Trent Palmer and Mike Patey, and videos like that about short takeoff and landing planes, and I thought that was all very interesting, so I thought maybe I should try and make a plane like that. Of course, to take off on that rough gravel, it would probably have to be fairly large, so I thought about maybe making a big plane, and I thought the bigger I go, the more likely it is that I can use hardware store materials, which are typically used for building fences and decks and all that kind of stuff. But if you're making a big enough plane, a large piece of wood suddenly becomes reasonable to use. So the materials that I've been making this plane from so far are 4mm plywood, which they don't actually sell at the hardware store. They sell tiny little bits of 3mm plywood, which is what I've been using so far. That's what I use for this. But with the size of the plane that I was going for, I didn't want to do that, so I found a place in Henderson called Plyman, which sells all kinds of plywoods, and the smallest one, the thinnest type they had, was 4mm, so that's what I've been using for this. And they sell it in these massive sheets there, so that's actually a quarter of the 2.4 by 1.2 meter sheets that they sell, and I got them to cut that into quarters for me, and they were very nice guys there, and they actually gave me this piece here for free, which to them is a small piece. This was in their offcuts bin. That's 18mm thick, and they just gave me that for free, so I made a cheap-ass table saw out of it, because part of what I wanted to do with the plywood was to cut it down the 1.2 meter length like that to make these pieces, not these particular pieces, these are just some of my tests, but these are about 12mm wide, and they're going to be the stringers for the underneath the wing skin, and obviously that's the ribs there. And as part of getting this project ready, I had to buy a scroll saw because these pieces are too large for my CNC machine to do. So my CNC machine has been doing some carbon fibre there, but it's not big enough to do these. If you look at like where the end of that airfoil is going to have to go, it just doesn't do it, unfortunately. So that's why I got this from Gary on Trade Me. It's been very, very helpful. Yeah, more than enough size-wise for what I need to do, and you can see I've been cutting out lots of bits there to get this done. Right, so another reason I wanted to try this plane in this scale, at least, is because I got it into my head that I wanted to try using something called high-impact polystyrene as a wing skin, because I don't really like that covering film that people typically use to skin the wing of a plane. I just can never seem to iron it on properly, at least to my satisfaction, and it seems a bit flimsy for a surface where you have widely spaced ribs, which is what I was thinking to do. Otherwise I would be cutting more of these than I could feel like doing, was sort of my thinking. And I'd been watching other videos on YouTube, and the term stressed skin came along in one of the videos, and it sort of stuck in my head for some reason, and I thought, oh, that sounds like a cool thing. Maybe I can make a wing where the skin of the wing is actually taking quite a lot of the structural load, and didn't seem like the covering film would be a very good thing for that. So I located a place that sells this stuff, which is actually what I have here, and they sell this in about 1.3 metre by 76 centimetre sheets. So this became the limiting factor on the length of a single wing that I could make. Actually no, the 1.2 metres there is the limiting factor on the size of the wing, isn't it? Anyway, this is called high impact polystyrene, which you are all familiar with, of course. No? Yes? Some people might have not recognised the name, but for those of you that didn't recognise the name high impact polystyrene, it's this stuff. At least if you look on the bottom and it says 6, that will be some kind of polystyrene, I think. So anyway, this particular one is, I think it's the same as the material that I've got here, except the material that I've got here is 0.6 millimeters thick. This stuff, just to sort of give you an idea of what I'm dealing with here, the top edge of this is approximately 0.9 to 1 millimeters thick. The side walls are about 0.1 to 0.2 millimeters thick, and the bottom is typically about 0.3 millimeters thick. So this stuff here is twice as thick as the bottom of this. So it's admittedly it's heavier than I wanted, but this was the thinnest I could find in large sizes and sheets at a price. Well, actually I couldn't find anything thinner than that, so never mind about the price. But I found this at a place called Cambrian Plastics, also in Henderson, and I just by chance checked my phone for plywood places as I was leaving Henderson and discovered the Plyman. So that's how I ended up with the plywood in the same trip. So I got a few sheets of this in 0.6 to try making wing skins with, and I also got one in 1.8 millimeter, which is rather thicker, and it's not going to be any good for planes, but I'm also thinking I might try this with making, well, we'll see how it goes. I don't know. May never use it for anything, but anyway. So yeah, I just wanted to done quite a few little tests with this stuff, so it remains to be seen whether it's any good for plane skins, wing skins, at least in this scale. So the scale I'm going for is 2.8 meter wingspan. So each wing is going to be, like I said, 1.2 meters long. So that's 2.4 meters of wing, and then the fuselage is 20 centimeters, so 2.8 wingspan in total. But just to give you a better idea of what we're dealing with here, I made a little list of all the features of this material. So puncturability, obviously the name high impact polystyrene implies, at least I think that's what it means, it's that it's fairly impervious to this sort of a, well, no, okay, now you've proved me wrong, but it's pretty good as far as stabbing and taking a hit from something sharp. So it's, okay, see, you can see I'm right-handed, huh? Holding the camera. But it's not actually going through there. It's making a large dent. But so it's fairly good puncture-wise. Cuttability, it's fairly easy to cut. I can cut through this with just a box cutter, craft knife sort of thing. Takes a fairly firm press, but also with a pair of scissors. Okay, this is tricky to do with one hand too, but you can see it's pretty easy just to cut with scissors. So it's fairly easy to work with. Has a smooth surface, obviously, which is nice. It's bendable, as you can see here, and more to the point, it doesn't crinkle very easily. Like, it doesn't form a sharp bend. Like, if I wanted it to bend sharply, it also doesn't like take on that bend very easily either. So you have to hold it in place like that. If I wanted that to crinkle, I could get it to crinkle. I just have to really squeeze it there. And now you can see it does crinkle, but it's not a sharp crease. It's sort of fairly rounded. Anyway, so this is one of my first tests just to make sure that it was going to be suitable for this. So obviously you'd make the starting and ending point here, and then this becomes the important question: how well is it going to conform to this shape without going weird? But as you can see, let me just put it down there. You can see is bend around there very nicely. Very nice round leading edge, which apparently is fairly important if you are trying to make a short takeoff and landing, or more to the point, it helps to keep your stability at low speeds. Yeah, so this plane, obviously I'm trying to make something in the style of a short takeoff and landing plane, but the weight, so far it's looking like it's going to weigh about 7 kilos. So whether it's going to be short takeoff and landing, I'm not so sure about that, but I'm pretty sure it will fly. Anyway, back to this. Okay, so glue ability, I did a few tests over here. Turns out that, interestingly, the best glue that I've come across so far is just good old super glue, and that sticks it pretty good. ADOS is not bad. This is ADOS here. I don't know if you have that overseas, but not sure. Is this a New Zealand thing or what? I've never heard anybody else on YouTube talking about that. Gorilla Glue, surprisingly not too bad. This stuff here is Tiger Glue, Tarzan's Grip. I just came across this in the hardware store when I was buying the other stuff, and I thought I'd give it a try. But it seems to be basically just Gorilla Glue, I think. It doesn't foam up quite as much though, so I wasn't too impressed with that, to be honest. It works quite well on metal and wood together like that. That's the same thing there. And I did another glue test somewhere, epoxy doesn't work at all. Yeah, forget about it. So anyway, that's glue ability. Screw, shear, tensile. This is sort of my second test that I made, and my plan is to put a bunch of stringers like that, see along the top, just there, that's what those plywood pieces will be, and into that I'm going to screw some little screws, probably a little bit more closely spaced than that. And these ribs here are 25 centimeters apart, which leaves, so there's a support underneath here, and then there's nothing at all in here. But to be honest, this actually might be flyable. It's just not very strong if you're making a longer piece of it. So what I've decided to do is go for 15 centimeters, which would be about from here to about here, and same number of stringers across the top, so it's only going to be 3, and then I think 2 on the bottom. Yeah, something like that. So I'm hoping that'll be alright. It won't be quite this soft, but it will still be a little bit soft, but I don't think it'll be a huge deal. Anyway, so yeah, these are easy to screw in with just a screwdriver. You just put the screw on there, poke the self-tapping screw, of course, poke the point of the screw in a little bit, and then if you have an electric screwdriver, it helps a lot. Just go bzzz, and set the torque setting of the electric screwdriver to the lowest position. You just go bzzz, 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 and it's actually quite quick and easy. And if you're lucky, it doesn't always happen, but sometimes you get it to go like this, and these screws I'm using are slightly countersunk, like that, just those ones. And it sort of countersinks itself, and then if you wanted to, you could put a piece of tape over that and it becomes perfectly flat, which is kind of nice. So what was I talking about? Tensile. Is it? Yeah. So it's quite good tensile strength. I don't know how much force you'd have to put on it to like pull it apart, but unfortunately, if you have a small piece, so what I've done here as a test is I put one of those screws in there, and then I just pulled on it from the side to see how easily it would shear, because I was sort of curious about how well each one of these screws would hold in, and unfortunately not too well. I probably, just from memory, I put probably about 1 kilo of sideways force on that before it broke. That's just one screw though, so if there are multiple screws like that, obviously, well, hopefully you need a lot more than 1 kilo sideways force to get something like that started. And unfortunately, once that starts, it does continue very easily. So that's a bit of a negative. Heat forming. This is one of the interesting things about this stuff. You can just heat it up and change the shape of it very, very easily. So this piece here, I heated up with the hot air gun for about, I don't know, 10 seconds, probably less than 10 seconds actually. And then I just folded it around this little piece of wood, and you can see it's folded around there. And then it remains in that shape quite strongly. So people use this to form around things. I've seen a lot of videos on YouTube where they use a vacuum table to heat up a big sheet. They'll heat up a big sheet of this stuff, then they'll have something on the vacuum table in the middle that they want to form it around, and then they'll just use a frame with the softened polystyrene over the top, and then the vacuum table will suck it all down. I'll see if I can find a video that I saw on YouTube and put a little bit of that in here so you'll see what I mean instead of just talking about it. Tape stick. Yeah, pretty much any tape that I've tried sticks onto it quite nicely, just packing tape or masking tape or yeah, just whatever. It's very easy to stick tape to and holds quite well, which is good, but it's also easy to get off, so it's about the best surface that I've noticed so far. Or EPO is pretty good, but this is probably about the same as EPO. Drawing and painting, as you can see here, stuff gets onto it pretty quick and easy, and you can very, very easily just draw or paint onto it. I haven't tried paint, but just from drawing on it with pens and pencils, I'd say paint would stick to it pretty easily, so that's good. Weight is a negative. It's I think it's just over 1 gram per cubic centimetre. So this sheet here is 620 grams, and I'm going to be using most of that, about 510 grams I think, for one wing. So I'm going to end up with a little over 1 kilogram of this stuff on my plane just for the wings. So that's 1 kilogram of the 7 kilos for the whole plane will be this stuff. So that's a bit of a bummer, but hopefully if it does have all the strength and all the other nice features that I've seen, it might not be such a negative. Price. I got one of these sheets for $6.50 New Zealand dollars, which is probably less than $5 US. So price is basically not a big deal. Availability, well, I had to drive into Auckland to get it, so you can't just get it any old place. But having said that place in Auckland, they seem to have fairly good stock of it. And you can get it in black as well if you wanted to, but obviously white is a little bit more easy if you want to paint it and stuff. Right, so that concludes my rambling about this stuff, but just in case anybody is curious about using this, and like I say, I don't know myself how well this is going to go yet, but at least I do know a lot about this material that I didn't know a few weeks ago, and now you know too, so isn't that nice? So as I mentioned, most of the materials for this came from the hardware store. In fact, I should probably get a sponsorship from Mitre 10. I've spent so much money there. So most of it is made up of these 12mm square clears, as they call them, and I used some of this which is 30 by 10mm for the spars, and I also used a little bit of 10mm dowel and also some 12mm dowel in some places. So that's pretty much all the wood. For the wheels, I first looked around on Hobby King and Banggood to see if there were any available that might be suitable, but I think I'm going to have something pretty large diameter, and they didn't really have anything quite what I wanted, so I thought I might try making my own. This is some kind of insulation foam that you would use on hot water pipes or something, I think, and it's a little bit like pool noodle material except slightly softer and a little bit more compressible, and quite conveniently has a split. Sorry, it's a bit hard to see there. Split all the way down it there. So I thought I might just cut out some circular pieces of plywood and stick this around the outside as a tire. So yeah, we'll see how that goes. I also used a little bit of this stuff, which is for putting on the edges of windows or something, I think. But I found it quite convenient if you just cut it into sort of 10 or 12mm pieces like that. You get a nice sort of a square piece that you can use as a extra little piece of bracing for a 90-degree joint in the framework. And of course there are some pieces of aluminium that I used as well. This is just one of the ones that I happen to have here. Didn't actually use any flat bar much, but some larger pieces of angle and also one piece of channel for the central section where the spars will go into. But I think what I'll do now is I'll just go onto the computer and show you a little bit about some of the design things that I was thinking of, and we'll look at the CAD sketches that I made while I was figuring out how everything would fit together.
Okay, so this is my CAD file. It's a bit of a mess because I did almost all of my working in here before I shifted some things to other files to print onto paper and cut them out and so on. But you can get an idea of what I was thinking from these pictures here, probably would be the best. So it's a tail dragger, which seemed to me would probably be the easiest way to get over those bumpy gravel surfaces and that, and remain stable. And I have a wheel on the back here, though. I'm thinking I might try just a piece of garden hose to begin with, and make it so that the garden hose is just long enough so that it has a bit of flexibleness at the end, so that it can turn a little bit to one side or another. And my original plan was to have one motor, and I bought a motor, which we'll have a look at in a minute, and I'm thinking that one motor with 4S batteries just not going to cut it. 16-inch props is probably what it's going to be. So I have 3 motors drawn on here, but I'm not going to do that. I'll just go with 2 motors, I think. So I will have one on the second rib on each wing. Haven't actually figured out how I'm going to mount those exactly yet. The second lot of motors, these 2 motors here, are different to this one. Slightly higher kV, because when I tried this one it just wasn't very... This was a 500 kV one that I got, and on 4S it just wasn't really putting out much power. I had it spinning up with the prop on next to me on the bench, and sounds a bit funny to say, but I wasn't really scared of it. It didn't have that sort of powerful sort of feeling to it, like it wasn't even really moving much air is what it seemed like. So yeah, I don't think that will do the job. So yeah, 2 motors is how it's going to end up, I think. And looking at the planform here, you can see that the wings and the flaperons, so these are full length flaperons. Seems a bit excessive, but I think you can include these as part of the wing area a little bit. And I read somewhere on RC groups, I did a lot of reading on RC groups and other sites and watching things on YouTube and everything to get a lot of ideas, and this seemed like a simple way to... It's quite simple to construct, because it means that you can construct the wing completely separate, well, not completely separately, but pretty much separately from the flaperons. You don't have to really think too much about integrating them, which is quite nice. It means your ribs can be made much simpler, and the whole structure is just a lot easier to make. What else can we talk about? The rest of it's pretty standard, I think. So hopefully it's going to sit on the ground in that sort of attitude. So these are my first designs for ribs. I was originally thinking about having 3 spars, so 2 clears. These are 12mm clears, and then an angle aluminium there. And I went through many iterations before I came up with not that one, but this is what I've ended up with. So I have 12mm clear and an angle aluminium at the back. Then I have aluminium channel in the middle. The yellow pieces will be on the fuselage, and then another piece of aluminium angle in there, and then a wooden spar. So these are glued together, and I'll show you some photos of how this was all put together. And each of the ribs, well, not all of them, but at some points they need to change, because from this point onwards the channel is no longer there, because it's only present in the middle. So this is the middle, fuselage will be there. Oh, I meant to not ramble on about this for too much, so I already skipped one of the major points, which was so those flaperons, I'm doing them like this, which is a Junkers style flaperon, which means that it's sort of separated out from the wing and it's a little bit lower. This one's actually balanced like that, which I haven't bothered to do. Hopefully it won't matter too much. And this, apparently the air, the higher pressure air under the wing, some of it comes through here, and it has a pulling effect on air that would be around about here, so that instead of separating from the wing as much as it normally would, it gets like this air that would be turbulent, instead of just sort of being turbulent here, it tends to be pulled down a bit here, and that has the overall effect of keeping the flow more laminar for further down the wing, is how it seems to work. So this plane here, actually the guy who designed this has a really good page where he explains all of the major points of it and why he did it the way he did it, and makes a pretty good case. And he makes a really good case for a tricycle undercarriage too, but I didn't really want to do that. So here again we see something very similar to what I've ended up with. Junkers style flaps. And if we look at a close-up of that, this photo was quite helpful for me to sort of figure out how to arrange it. They actually pivot so that when the flaps go down, they actually go back as well. So they're extending the wing chord as they go down and back, and then when they come up, they also go forwards a little bit. But they always have a bit of a gap here. Mine will not have a gap there all the time. But anyway, that's where I got that idea from. And it seems like a pretty good idea for slow speed stability as far as I can tell. So I did have a picture here. This is sort of what it's going to look like when it's at full up extension. So my hinge arrangement is not as good as what we just saw in that photo. It's not quite positioned as well, and it doesn't have that nicely shaped surface. So I think the idea with this curve here, it's actually, I thought it was arranged so that this gap wouldn't change, but I don't know, maybe it does, I don't know. But anyway, my gap is going to change significantly, so you can see the one I've selected here is going to be closing off that gap pretty much, but then when the flaps are down, that gap should be quite open and prominent. Anyway, so servo's going to go in there. You'll see more of this in the photos later on. These are my carbon fiber parts that I made, so these are the mounts for the flaps. These are some reinforcing that I had to make for the ribs, because this part of the rib here I found is quite weak, especially this point here is a sort of a stress riser that I actually broke one of them quite easily. So I decided that all of the ribs that did not have this carbon fiber piece on the back would get one of these extra pieces of plywood just to double up the thickness. This is some other carbon fiber bits. So yeah, that's this is hopefully what it's going to look like at the front. So the landing gear, I'm thinking to just make this from one piece of aluminium flat bar. I think it's 5 centimeters wide by 3 millimeters, and that may end up being a little bit heavy, so I might make it of something a little bit smaller. But what else to look at? That's about it probably. So I gradually took pieces of this file and shifted them out into other files to make plans where I could actually print something out and build from the plans. So this is the top of the fuselage. This is the main piece of the vertical stabilizer, horizontal stabilizer, and I just sort of tried to do that three-dimensional Tetris, sort of arranging things mentally to figure out how it was all going to fit together. It's changed a little bit since then, but you can see I've just sort of figured out where I'm going to put holes for to mount everything together and so on. And you have to make sure that everything's going to be free to move. Like this piece here has to have a little bit of space around it to rotate, and so on. So it all took quite a bit of thinking, but fortunately it has all worked out fairly well. So what I was hoping to do is show you a whole bunch of photos of constructing it in this video, but unfortunately this video's got a fair bit longer than I would like already, and with the way that my internet connection is at the moment, I don't really want to be making and uploading large videos. So unfortunately I'm just going to have to cut this here, and then we'll go on to the photos of the construction in the next video.